Welcome back. I'm going to introduce to you now another property of arithmetic progression. We have seen the general term, then we have seen when we have odd numbers of terms, we can write the equation like this. The good thing about writing the equation like this, an plus z minus z plus 2z minus 2d and so on. To write the sequence focusing on the central term. Why is that? Because when we make the summation of all the terms, we just get ans, and that's very easy to work with because the common difference, the d, disappears when you just add everybody. And we have seen the third property that we can find, like number 7, just averaging the neighbors, like 5 and 9. So when we just add 5 and a 9, this is 14, and the average, it is 7. The average between 7 and 11, it is 9. The middle point, right? Okay. And now I'm going to introduce to you the equidistant. When we have equidistant terms, they are always going to sum the same. For instance, let's suppose we have this sequence, and if we just add 5 with 11, this is going to be 16. 7 and 9 is also going to be 16. Okay, so this is the property I'm going to introduce to you. Let's call it number 4. Okay, what is this? This is just the Roman, okay, numerals. Okay, we have the capital letter and we have the small letters. Okay, this is I and the V. This is just 4, right? Okay, so we're going to introduce now this idea of equidistant terms. Equidistant terms. Of course, in arithmetic progression sequence. And I'm going to write like this. The sum of two equidistant terms in a finite, of course it must be a finite, arithmetic progression is equal to the sum of the extremes. Okay? And when I say the sum of two equidistant terms in a finite arithmetic progression is equal to the sum of the extremes, and this is also true for all equidistant terms, okay? Let's put in here. This is also true for all equidistant terms. So, for instance, let's suppose we just have the numbers like 2, 4, 6, 8, 10, for instance. Okay, well, we're going to, okay, this is our sequence. That's how we represent our sequence, and this is a central term. Let's make it green. As you have noticed, I love colors. And what do we have in here? Well, the 4 and 8 are equidistant. So if we just add 4 plus 8, we're going to get 12. But the 2 and the 10 are also equidistant from the center. Okay? And if we just add all those pairs, equidistant pairs, 2 plus 10, we are also going to get a 12. And if you ask me, what about the 6? Well, the 6 is alone, right? So he's going to have a pair with itself. So we can just put like 6 plus 6, it's a 12. So we can say that if we add those equidistant terms, of course equidistant in relation to the extremities, this summation, it is always going to be the same for the entire sequence. So every equidistant term, if we just add both of them, they're going to be the same. So if I add those two, they're going to have to be 12, those two 12, those two 12, and so on. Okay, and in case our sequence, okay, let's write it down. Okay, this property. In case we have odd number of terms, the central term will be half of this summation, meaning the central term will be half the summation of the equidistant terms. And this is what I'm saying. 6, it is central. 6, it is going to be half of 4 plus 8, because 4 and 8 are equidistant. Okay, and if you just remember, this is the same as saying 6 is the average of 4 and 8. Okay, we just have seen this, right? Okay, so this property number 4 is just like property number 3 written in a different way. Remember, each term of the AP, it is the average of its surrounding terms. Okay, it is the same thing. So this property, it is interesting. Okay, let me see if there is anything else. No, it's everything is all right. Okay, it is just that. Okay, so I just want you to understand. Oh, and let me give you another example. When, for instance, we have maybe we have okay, I'm not going to write another one. I'm just going to imagine now that we have, let me put this way, let me cover this and let me cover this one. Imagine now our sequence, it is just that 2, 4, 6, 8. What is going to be the central term? 4 and 6. So 4 and 6 must be 10. This is 10, right? 2 and 8 must also be 10. No problems? Okay, so when we have even amount of terms, the same works. Okay, but when we have odd numbers, the central term, it is just going to be added to itself, right? Nothing new in here. Okay, there is anything else for him to add to. Okay, so next page we're starting some exercises.